Hey guys, welcome to the Chapter 5 test review. We are reviewing today sections 5.4 through 5.6. Let's go. The graph of f of x equals quantity x minus 2 squared is shown. So here is the graph of x minus 2 quantity squared. They want you to graph negative f of x and f of negative x. So remember, whenever the negative is on the outside of the function, this is the negative is on the function, it's going to reflect over the x-axis. When the negative is on the inside of the function, it reflects over the y-axis. So there's two ways to describe that. So the first one, being with the negative on the outside, means we're going to do a reflection about y equals 0. Another way to describe that is about the x-axis. So that's this guy right here, which means we're going to take this graph and we're going to reflect it over that line, which basically means, if you can imagine, folding this paper and placing it on top of the other side. So for instance, this point right here would land on this spot, and this point right here would land on that spot. So I'm going to go ahead, I'm going to plot those points. Alright, so as you can see, this point came from up here, and this point came from a reflection up there. This one came from all the way up there, and so did this one. So the reflection, I would go ahead and draw, and it would just basically look like an upside down version of this graph. And that's when the negative is on the outside. If the negative is on the inside, then we reflect over the x equals 0 line, or the y-axis, which means now this graph would go over to this side. So this point right here, since it's 1, 2, 3, 4 units to the right, I would reflect it 4 units to the left, and it would go onto that spot right there. So that's what right there. And then this point would actually stay on the y-axis, and this point would reflect over onto this part. So that would go right here. This point would reflect over to here. You could say, well, it's 1 away to the right, so it's going to be 1 away to the left. So it would go here, and his partner would go on that side. So connecting these two, that would give me my f of negative x. And then the other one is your negative on the outside of x. So for the pink one, f of negative x is a reflection about x equals 0, also known as the y-axis. All right, moving on. Write 1 over 100,000 as a single power. So they want you to rewrite this number using an exponent. That's what power means. And because he's in the denominator, my exponent is going to be negative. So I first need to tackle, how can I rewrite 100,000 using just a number? Well, I know 100,000 is the same thing as 10 times 10, that's 100, times another 10, that's 1,000, times another 10, that's 10,000, times one more 10. This would give us 100,000. I also know, because count how many zeros I have. 1, 2, 3, 4, 5. So it's going to take 1, 2, 3, 4, 5 tens in order to obtain that decimal, or that value place. All right, so I now know that 1 over 100,000 can be rewritten as 1 over 10 to the 5th, but they want it as a single power, which means as a single number. So what I have to remember is that to move 10 up to the numerator, it has to have a negative exponent. So that would be the same thing as 10 to the negative 5. And that would be my answer. Write the function f of x equals negative 2 raised to the x reflected about the horizontal line y equals 0. So whenever that y is out here and it's reflected about y equals 0, all we need to do is put a negative on the outside. So if I put a negative on the outside, I have a negative 2 already there raised to the x. These negatives would cancel, and I would be left with just 2 raised to the x. And that was all because this just said about y equals 0. If it said a vertical line, and it said x equals 0, well, then that's the x-axis. If it said x equals 0, then I would need to put a negative sign on the x itself. So that one would be negative 2 to the negative x. So that would be a vertical line about x equals 0, and the other was a horizontal line about y equals 0, and that gave me the negative in the front. Write the equation that has the following 4 characteristics. Is an exponential function, that's this guy right here. Exponential function means the x is in the exponent. Is continuous. If we were graphing, that would just mean that all the lines would be connected. Is increasing, that means it's going to be starting down low and going up. And is translated 3 units up. So 3 units up. That means it's going to be a big 3 on the outside. And look, just like that. That would be 3 units up. If it was 3 units down, sorry, let me erase that. I want to do a different color. If it was 3 units down, then it would have been 5 raised to the x minus 3. If it was 3 units to the right, then because it's moving along the x-axis, which moves left and right, it's going to go into the exponent spot. So it would be 5 raised to the x minus 3 because it's opposite sign when we're in the exponent. So even though we're going to the right, it's still going to be a minus sign. And last but not least, if we're going 3 units to the left, then it would be 5 raised to the x plus 3. Notice that up and down are big numbers out front. Left and right are tiny numbers in the exponent. What is cube root of 8 and what is the cube root of negative 27? So these questions are asking you, whenever there's a 3 sitting here, it wants to know what number, when you multiply it to itself 3 times, gives you 8. So we need to think about it. What number, when you multiply it to itself 3 times, gives you 8? So we've done this one several times. That's going to be 2 times 2 times 2. And 2 times 2 is 4, times another 2 is 8. So my answer here, the cube root of 8, is simply 2. Because 2 times 2 times 2 is 8. So 2 is called the cube root of 8. 8 is called the radicand, and 3 is called the index. Okay, now they want us to do the cube root of negative 27. So if 2 times 2 times 2 is 8, then I know 2 is not going to be an option. So let's try the next number up. 3 times 3 times 3. If I do that, I get 9 times 3, which is 27. But this was a negative 27, which means that's got to be a negative 3. So negative 3 times negative 3 times negative 3. That would result in a negative 27. So the cube root of negative 27 is negative 3. All right, what is the solution to the exponential equation 27 equals 3 raised to the x minus 1? So just in case you need to remind yourself of the steps, we took notes on page 352 for this section. So remember, the very first step we have to do is to rewrite so we have the same base number. So right now we have a 27 and a 3. So I need to rewrite this so they both have a base number of 3. So the first thing I need to do is figure out how I can take 3, that's my common base, and use it to get 27. So let's see how many times it takes for me to multiply 3 before I get to 27. And 3 times 3 is 9, times another 3 is actually 27. So count, there's 1, 2, 3 of them. So that means 3 to the third is the exact same thing as 27. So I'm going to take 27 out and replace it with 3 to the third equals 3 to the x minus 1. The next step is the set exponents equal to each other. So my exponents are going to be equal. Because I have the same base, I can set my exponents equal. So that's these two guys are going to go into an equation, and I'm going to make them equal to each other. So that would be 3 equals x minus 1. So that's the second step. The third step is to solve for x. So that means get x by itself. So I first need to move over this number, and I would do that by adding 1 to both sides. 3 plus 1 is 4, so 4 is equal to x. So my answer for this problem is plainly 4. The velocity v in meters per second of a free-falling object that has fallen h meters is given by the equation v equals radical 2 times 9.8 h. If an object is dropped from a height of 72 meters, what is the velocity of the object when it hits the ground? So we're taking 72 and we're plugging it into height. As simple as that. So I got volume equals the square root of 2 times 9.8 times 72. So first things first, let's go ahead and go to our calculator and plug all of that into the calculator. When I do that, I get an answer of 1,411.2. But I still have the radical over it, so then now you have to do the square root of that answer, of that number, and that's where we get 37.56. They want us to round to the nearest tenth, so then my answer would be 37.6. What is the solution to the exponential equation 1 over 32 equals 2 raised to the x plus 1? So first and foremost, notice that this is a 2 and this is a 32, which means I need to rewrite 32 as 2 to some power. So let's go in and let's figure out how many 2's it takes. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So there's our 2. How many did that take? 1, 2, 3, 4, 5. So 2 to the 5th power is definitely 32. The problem is this is 1 over 32. So this would be 1 over 2 to the 5th. So to move it up to the top, it would have to be a negative. So it would be 2 to the negative 5. All right, so doing our steps, let's go ahead and rewrite it. So the first thing would be 2 to the negative 5 equals 2 to the x plus 1. The second step would be to set the exponents equal. Those are these guys. So that would be negative 5 equals x plus 1. The third step is to solve for x, which means get rid of the 1. So negative 5 minus 1 is negative 6, and negative 1 plus 1 would cancel out and we're left with just x. So my answer would be x equals negative 6. Write each expression in radical form. So radical form means my answer is going to have a radical in it. Remember, this is my index number. He goes into that little hammocky spot right there. And he is my power. He's going to go inside in that power position. The leftover number, which is 7, goes inside, and that's what everything goes around. So I have radical 7 to the 1st power, and it's a square root. But remember, this 2 and this 1 are both understood without you having to write it. So that answer could be simplified down to radical 7. Okay, with this one, this guy is going to be my power, and he's going to be my index. So I go and I make my radical sign. The 3 goes in the index spot, and then, and then x goes into the radical, and then a power of 1. But you can clean that up by simply 3 radical x. Kennedy graphed the function f of x equals 12x. Write a function that is a reflection of the function about the vertical line x equals 0. That means that the negative goes on the x. Write a function that is a reflection of the function about the horizontal line y equals 0. That means the negative is going to go on the outside. So about x equals 0 means that the negative is going to go on the x. So that would be negative 12. That is about x equals 0. And then about y equals 0, that would be f of x equals negative 12 raised to the x. Notice the negative is on the outside if it's about y equals 0, and the negative is on the inside if it's about x equals 0. Write each expression in rational exponent form. Rational just means that it's going to be a fraction. So don't let that word bog you down. It just means that your exponent is going to be a fraction. So right here, this has a power of 1. That's going to be my numerator. And then my denominator is going to be the index. So numerator, denominator, and this number is your base. So this would be 6 raised to the 1/3, which is not the same thing as 6 times 1/3, which is just basically 2. Not the same thing. This is 6 raised to the 1/3. Okay, the square root of 13, that would be, there's a 2 here even though we don't see it, and a 1 there, so that would be 13 to the 1/2. Right here, this is going to be my denominator, and the 7 is going to be my numerator. So it would be 3 raised to the 7/5. And last but not least, I've got the cube root of x to the 6. So that would be x raised to the 6/3, but you would not leave 6/3 as an answer. You would need to reduce that down to x squared. Okay guys, so what I want you to do on this last one is go into your sections 5.4 through 5.6 and look up all of these definitions and know them for tomorrow's test. These are 7 questions that you know will be on the test tomorrow. All right guys, thanks so much for watching. I hope we do fantastic on the test. See you in class.